the remainder and factor theorems. So they're going to give us one of our zeros, our solutions, our x-intercepts, and we're going to plug that in and evaluate this, okay? But we're going to do it using synthetic division. So I could take the -2 and plug it in here, or I could use the remainder theorem and do it by synthetic division. So I'm going to take that number and I'm going to plug it in on the outside of the big L-shaped box. And then always make sure you're not missing anything. So if I start with x to the third, then I've got x to the second, x to the first, and then no x. So I've got 3, 8, 5, and -7. So I'm dropping the 3, and then I'm multiplying. 3 times -2 gives me -6. And then I add that to the 8. That gives me 2. Times -2 gives me -4. Plus the 5 gives me a +1. Times -2 is -2. And then I add that to the -7, which gives me -9. So when you plug in -2, you get -9. So you would say f of -2. So when I plug in -2, I get -9. Our number 11. Same thing. We're going to put that -3 that they gave us on the outside. Make sure that I'm not missing anything after my biggest power. So 3, 2, 1, and then no x. So I've got a 1, a 5, -1, and -4. Drop down 1 times -3 is -3. Plus 5 is 2. Times -3 is -6. Plus -1 is -7. Times -3 is +21. Plus a -4 is 17. So when I plug in -3, I get 17. All right, on number 12, we're going to show that x minus 2 and x minus 3 are factors of that great big polynomial. And the way I can do that is I know that something's a factor if it will divide evenly into something. So for instance, I know that 3 is a factor of 9 because 9 divided by 3 comes out to be an integer, right? Or I know that 2 is a factor of 10 because 10 divided by 2 is 5, right? So if something divides evenly, then I know that it's a factor of that polynomial. Well, since this is just x minus 2 and x plus 3, I can use synthetic division, and as long as I get a remainder of 0, then it shows that it divides evenly, right? So if I were to set the x minus 2 equal to 0, that would give me a positive 2. And then I'm starting with x to the fourth, so I should have an x to the third, x to the second, x to the first, and then a term without the x. So I've got 2, 7, -4, -27, and -18. So I'm going to drop down this 2 and multiply. 2 times 2 is 4. 4 plus 7 is 11. Times 2 is 22. Plus a -4 is 18. 18 times 2 is 36. 36 minus 27, that would be 9. 9 times 2 is 18. And when I add those, I get a remainder of 0. So I know that 2, all right, that factor of x minus 2 is a factor of this whole polynomial, so it divides evenly. So I'm going to do the same thing with x plus 3. If I want to do that synthetically, though, I would set the x plus 3 equal to 0, which would give me a -3. And then we do the same process. So I've got the 2, the 7, negative 4, negative 27, and negative 18. So I'll drop the 2. 2 times negative 3 is negative 6, plus 7 is 1, times negative 3 is negative 3, plus a negative 4 is negative 7, times negative 3, positive 21, minus 27, that gives me 6, negative 6, and negative 6 times negative 3 is positive 18, which gives me a remainder of 0. So now, since I got remainders of 0 on both, that shows that both of these binomials are factors of this whole polynomial. We're going to show that x plus 2 is a factor of this polynomial. Now, I don't care about this part, okay? Really, this is the polynomial I'm looking at, okay? So first I'm going to show that that's a factor, and then I'm going to find the remaining factors, okay? I should have 3 total factors because there are 3 zeros. That's your biggest one, right? So if I set x plus 2 equal to 0, that means I would have a negative 2 on the outside. And I'm missing my x squared, so I want to make sure that I put a 0 there. So I've got 1, 0, negative 28, negative 48. And I'm going to drop the 1. 1 times negative 2 is negative 2, plus 0 is negative 2, times negative 2 is 4, plus a negative 28 is negative 24, times 2, negative 2 is positive 48. So that one is a factor, right? So I've shown that it's a factor. Now it wants me to find the other factors, so that means I'm going to have to factor what I have left. So if I started with x to the third, this would be x to the second, x to the first, and then the term without the x. So I have to factor that polynomial. Since there's a 1 in the front, I don't have to do any kind of illegal move. But I look at the back, I've got a minus sign, so that's 1 plus, 1 minus. The x squared, I've got x times x. And I'm looking for what will multiply to make 24 and subtract to make 2. So what multiplies to make 24 and subtracts to make 2. Let's see, 24. We've got 24 and 1, 12 and 2, 6 and 4. So 6 and 4. And I want the middle term to be negative, so I'm going to put the bigger of those two right there. So your remaining factors are x plus 4 and x minus 6. It didn't ask for the remaining zeros. If it did, you would set them equal to 0 and solve for x. But it just asked for the remaining ones. And that gives me one factor, another factor, and then the third one was what they gave us originally. All right, so the rational zero test. This is like if I get a polynomial and I can't factor it. Then I can try to find my rational zeros and then go from there. And we'll use our calculator to kind of help in that. So you would take all the factors of the back number and divide those by all the factors of the front number, and then that makes a list of all your possible rational zeros. All right, so it says find the rational zeros of x cubed plus x plus 1. So this is an easy one to start out with. I'm just trying to figure out the most I could have, which would be 3. That doesn't mean I have 3 rational ones. That just means I have 3 zeros in total. They might be irrational, imaginary. So I'm going to look at this and I'm going to say, okay, I'm going to take all the factors of this back number. So the only thing that multiplies to make 1 is 1 and 1, right? And I divide that by all the factors of the leading coefficient, which is also 1. So if I were to take 1 and divide that by 1, that would give me 1. So we have two options here. We have a positive 1 and a negative 1. Now, I could take this and synthetically divide and see if the positive 1 would divide evenly, and then I could see if the negative 1 would divide evenly. Or I can use the calculator to do that for me. So grab your calculator. So we're going to go to the y equals, and we're going to put in x to the third plus x plus 1. So it told us that the possible ones were positive 1 and negative 1. So if I look at the graph of this, if 1's a 0, it's going to cross at 1. It's not crossing at 1. And if negative 1 is a 0, it's going to cross at negative 1. It doesn't cross at either of those. So this equation actually has no rational zeros. And if you look at the graph, you can actually see as well that it only crosses one time. So it only has one 0. Obviously, it's an irrational 0, okay? And it must have two imaginary ones because there's no other crossings, right? We just have one crossing. So if you take one of the real zeros away, then there's two imaginary ones. So if we were to actually sit there and try to factor and find all of those, you know, we'd figure that out. All right, so we're going to find the rational zeros of this equation. But we're going to go ahead and skip that one because I'm not going to give you any with the fraction there. So we'll skip to 16. We're going to find all the rational zeros. So the most we could have would be 3. You can't have more than 3. Now, I could have less than 3, all right, but not more than 3. So I'm going to look at the back number, and I'm going to list everything that multiplies to make 8. So you've got 1 times 8, and I like to kind of like separate them and do 1 and 8. And then you've got 2 and 4. And then the only thing in between 2 and 4 would be 3, and that doesn't divide by 8. All divided by the coefficient of the front, which is a 1. Now, if I were to take everything on top and divide it by 1, then all I'm going to get is everything that's on the top. So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So this is 8 options that we have right here. So we have to decide, okay, which one of these will work. Now, I could sit there and take this and synthetically divide it by every single one of these numbers until one of them came out to be 0. Or I could use my calculator to help with that. So if you grab the calculator and you graph it, we've got x to the third minus 5x squared plus 2x plus 8. You're going to look to see if any of those options, any of your 8 options, happens here. Okay, well, I can see it crosses at -1. That was one of my options. It looks like it's crossing at 2, and it looks like it's crossing at 4, which technically that would be all 3 of them, right? But we're going to go through the process anyways. So we'll pick one of these to divide by. I think I'm going to divide by 2. And if you're not sure if it's crossing evenly, if you go to your table and look at 2, see how you have a 0 there? So you know that that's an x-intercept right there. So I'm going to divide by 2, which was one of my options, right? A positive 2. So I look up here, I've got 1x to the third, negative 5x squared, 2x, and 8. Drop the 1. So 1 times 2 is 2, plus negative 5 is negative 3, times 2 is negative 6, plus 2, negative 4, times 2, negative 8, which gives me a remainder of 0. Now I have a couple of options here. Since this was an x to the third, this will be x to the second, and then I could factor, right? Or if I couldn't factor, I could plug into the quadratic formula. Or since I know a couple other zeros, I could divide again and divide again. I'm going to choose to factor because usually that's the thing that you have to do. So we know that 2 is one of our rational zeros, right? We don't want to forget about this one. And then since I started with x to the third, this would be x to the second minus 3x minus 4, and I'll factor. So at the back, I have a minus sign, so that gives me a positive and a negative. And then I've got my x squared, so x times x. And what multiplies to make 4 and subtracts to make 3, that would be 4 and 1. And I want the 3 to be negative, so I'm going to put the 4 with the negative and the 1 up front. Then I set those equal to 0. That gives me negative 1 and positive 4. And then I have 3 rational zeros. I have negative 1, 2, and 4. And I'm going to put those in a bracket. Just make sure you don't forget the 1 that you had up there that you synthetically divided by. So on number 17, we're going to do the same thing. The most I could have would be 3. That doesn't mean I'm going to have 3, but that's the most that I could have. Okay. So I'm going to look up here and I'm going to say, okay, factors of 3. The only thing that multiplies to make 3 would be 1 and 3. And then I look up here in the front of my biggest degreed term, and I've got a 2. So the only thing that multiplies to make 2 is 1 and 2. So since I have 2 terms on top and 2 terms on bottom, I'm going to take both terms on top and divide them by 1. And then both terms on top and divide them by 2. So if I take 1 divided by 1, that would be 1. And then 1 divided by, and then 3 divided by 1, that would be 3. Then I do 1 divided by 2, that would be 1/2. And then 3 divided by 2 is 3/2. So I have 8 options again. I have a positive 1 and a negative 1, a positive 3 and a negative 3, a positive 1/2 and a negative 1/2, positive 3/2, negative 3/2. So I have 4 options, or 8 options for possible rational ones. Okay? So I'm going to grab my calculator, go to my y equals, and I'm going to plug in my equation, 2x to the third plus 3x squared minus 8x plus 3. All right, so if you look at this, it looks like looks like negative 3 is an option, and it also looks like it's crossing at 1. But I'm going to go to my table, second graph, and if you look at 1, see how 1 has a 0? And it looks like negative 3 also has a 0. But those are the only 2, right? That other one doesn't cross evenly, so that might be like a positive 1/2. So what we'll do is we'll pick either the 1 or the negative 3 and synthetically divide by that. So I'm going to do the 1 because that's just easier to multiply by. So I started with a cube, put the 2 up front, and then I've got 3x squared, then the negative 8x, and the positive 3, and I go through the process. Drop the 2, times 1 is 2, plus 3, 5, times 1, 6, plus a negative 8, negative 2, oh, I got a problem somewhere, 2, Oh, this is 5. I can't multiply. 5 plus a negative is negative 3 times 1 is negative 3. Remainder of 0. All right, so now, since I started with x to the third, I can go ahead and say this would be 2x squared, 5x, and negative 3. So if I have a number in the front, then that means I don't have to multiply it times the back so that I can factor. So that would be x squared plus 5x minus 6. Then go ahead and do your factoring. You've got a minus at the back. That's going to be 1 plus 1 minus x and x. And what multiplies to make 6 and subtracts to make 5, that would be 6 and 1. And I want that to be positive in the middle, so I'm going to put the bigger number with the positive. But then I can't forget, once I get it factored, that I have to divide by that 2 to undo the illegal move. So divide both of these by 2. So that's going to give me x plus 3 and x minus 1/2. Now, normally, if I was just factoring, I'd pull that 2 up in front, but I'm going to set it equal to 0 anyways, so there's no reason to do that. So I've got x plus 3 equals 0, and x minus 1/2 equals 0. That gives me negative 3, and this over here gives me positive 1/2. So my answers are negative 3, 1/2, and don't forget about the 1 up at the top. So that actually makes sense, right? And if you really wanted to check the 1/2, it's kind of hard to see that that would be 1/2, right? I mean, we had 3/2 as an option as well. If you set your table to put your own numbers in, like if I go to second window and I change that independent to ask, then when you go back to your table, you can just put in the 1/2, and you can see that that's also a 0. So technically, you could check every single one that you had. If I plugged in negative 1, that was an option. Okay, that's not a 0, right? Let's see, negative 1/2 was also a possible. That one's not 0. Okay, 3 is not 0. 3/2, not a 0. Negative 3/2, not a 0. So, I mean, that's another way that you could check and say, okay, well, it looks like I'm just going to have 2 rational zeros, or it looks like I'm going to have whatever. You can check all of them, but sometimes that could be a little bit tedious if you had like a bunch of numbers. All right, so same thing on number 18. All right, so we've got 125. So I know that 1 and 125 make 125. And then you have, it doesn't divide by 2, doesn't divide by 3, doesn't divide by 4, 5 and 25. And then it doesn't divide by 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. And then I would divide that by the factors of 1, which is just 1. So these are my 4 options, and I have 3 at most, right? So I'm going to go ahead and I'm going to graph this so that I can decide which one of these is going to be the one that I'm going to use. So x to the third minus 15x squared plus 75x minus 125. All right, anytime this flattens right here, instead of just crossing, it's going to have some kind of multiplicity, right? If it curves on the x-axis, it has a multiplicity of 2. So it's possible that this could have 3, right? 1, 2, 3, 4, 5. That looks like 5. So if I go to my table and I plug in 5, I get a 0. So that's definitely, it looks like that's the only one where it crosses, so I'm going to do my synthetic division with 5. So I have x to the third, that's 1, negative 15 in front of my x squared, 75 in front of my x, and then negative 125. So drop the 1, times 5 is 5, plus a negative 15 is negative 10, times 5 is negative 50, plus 75 is a positive 25, times 5 is 125, which gives me a remainder of 0. So since I started with x to the third, then this would be x to the second, and then minus 10x plus 25. And if you need to write that so that you have all your signs, then that's fine. So we're going to factor. I have a plus at the back, which means I look up front, and I have 2 minus signs, x and x. And then what multiplies to make 25 and adds to make 10? That would be 5 times 5, right? And when the signs are the same and the numbers are the same, you don't have to worry about that. If I set these equal to 0, I'm going to get 5 here, right? I'm going to get 5 here. So I got 1 5, 2 5, 3 5s. So that would be 5. And then you would have to say multiplicity of 3. Okay. Last one of these. So I look at the back. I want to do all the factors of 30. So we've got 1 and 30. 30 divides by 2, so 2 and 15. 3 and 10. And then it doesn't divide by 4, 5 and 6. I like to do it this way. That way when you meet in the middle, then you know you're done, right? And then I'm going to divide that by all the factors of 2. So that would be 1 and 2. So you have to take everything on top and divide that by 1. And then everything on top divided by 2. So if I divide everything on top by 1, I just get everything on the top. So 1, 2, 3, 5, 6, 10, 15, and 30. Then you're going to take everything on top and divide it by 2. So 1 divided by 2, that's a half. 2 divided by 2, that's 1. And we already have that listed. Then we have 3 divided by 2. 5 divided by 2. 6 divided by 2 is 3. We already have that. 10 divided by 2 is 5. We have that. 15 divided by 2. And then 30 divided by 2 is 15, and we already have that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 24 possible zeros. And at most, rationally, we have 4 at most zeros, right? Now, all 4 of those may not be rational, but they could be. So to help aid in what we should divide by, we're going to graph it so that we don't have to, we can, not take the guessing game out of it. So we have 2x to the 4th minus 9x to the 3rd minus 18x squared plus 71x minus 30. Okay, so 1, 2, 3, 4 of them, right? Now, since this is to the 4th power, we probably want to make sure we divide twice. That way we can get down to an x squared. So it looks like it's crossing at maybe 2 and 5. So I'm going to check that in my table just to make sure. So if I plug in 2, I get a 0. If I plug in 5, I get a 0. So I think those are the two I'm going to divide by. So I've got 2. And I'm starting with x to the 4th, so you don't want to miss anything after that. So I've got a 2x to the 4th, then a negative 9, x to the 3rd, a negative 18x squared, a 71x, and a negative 30. So we'll drop the 2. 2 times 2 is 4, plus negative 9 is negative 5, times 2 is negative 10, plus a negative 18 is negative 28, times 2 is negative 56, negative 56 plus 71 is 15, and 15 times 2 is 30. So that one worked out. But if this is x to the 4th, that means this is x to the 3rd. And if I factor this, I'm going to have to do grouping. So if you have another 0 to divide by, then divide again. So we decided that it crossed at 5 as well. So we're going to divide again. And you're just going to drop these numbers that were left over from your first division down. So I've got 2, negative 5, negative 28, and 15. So I'm going to drop the 2. 2 times 5 is 10, plus negative 5 is 5, times 5 is 25, plus a negative 28 is negative 3, times 5 is negative 15, which gives me a remainder of 0. So as x to the 4th, this is x to the 3rd, which means this is x to the 2nd, which makes this 5x, and then minus 3. So since I have that number in front, I'm going to have to do the illegal move and multiply the 2 times the back. So that would give me x squared plus 5x minus 6. And then I'm going to go through the factor process. So I have a minus in the back. That gives me a plus and a minus. I've got my x times my x. And what multiplies to make 6 and subtracts to make 5, that would be 6 and 1. And I want the 5 to be positive, so I put the bigger number with the 6, or with the plus. Then once I factor, I got to remember to undo that. So I'm going to divide by 2. That gives me x plus 3 and x minus 1/2. And remember, if you're going to solve for x, there's no reason for you to move the 2 to the front. So if I set those equal to 0, that's going to give me negative 3 and a positive 1/2. So I have 4 of these all together, right? I have negative 3, 1/2, and then I also have 2 and 5. And I go from least to greatest. Just number them. So if you want to make sure that you're right on this, all you have to do is grab your calculator, go to your table, plug in negative 3, you got a 0, and then plug in 1/2, and you've got a 0. So this time it worked out where we had 4 all together.